Okay, percentage change is a great section to end the chapter on because it's short and sweet and students understand percent of change. But there are some tips and tricks that I want to show in this section. So introduction says that the Slow and Sloppy 7 already have matching t-shirts and bags, and they're now looking into embroidered hats. They are originally $40 and are now on sale for $32. So the question is, what percent off the original price did they save? Well, let's go ahead and look at how much money they saved. So looking between 40 and 32, it looks like they saved $8. Okay, well, what's that percent? Okay, so percent off original. We saved $8 of 40. So there's our ratio. We're comparing how much we saved versus how much it was to start with. So this is just a little bit of calculator work. If you plug that into your calculator, 8 divided by 40 is 2/10. And we understand that when we're looking at percents, if we multiply that by 100, that gives us 20%. So they saved 20% off the original price. Okay, technically what we did was, again, we looked at the change of the price. So anytime that we look at a change of value in math, we're technically subtracting. So we subtracted the new price versus the original. And then we always divide that by what we started with, the original. Okay, let's look at this for a second, because technically we subtracted the original minus the new. But the reason why we do this is if we took the 32 minus the 40, we would actually get a -8, which would give us a -2/10. Okay, what that negative means is just it was a 20% decrease in price. Sometimes we have an increase. So stick with this nice little formula and just understand that that negative, if you do get a negative in your problem, that just means that it's a decrease in price. Okay, so how much did they save? They saved 20%. All right, moving on. Sales tax, we should be pretty good at. South Dakota has a sales tax of 6%. So the hat on sale, which is $32, how much does that cost after tax? Again, a lot of students like to say, okay, well, I'm going to take 32 and I'm going to multiply that by 6%. Remember, in calculator, 6%, we move that decimal 2 to the left. Well, what that's going to do is that's going to give me how much the tax is. So we have to add on $1.92 to our price. So then from there, we have to add 32 to that. And we get a grand total of $33.92 per hat. Okay, I like to have as less amount of calculator work as possible. So I'm going to combine these two pieces. So what I'm going to do is I know that I have to pay an extra 6%. I also know that I have to pay 100% of what the hat cost. So I'm going to add that to 100%, which is 1. And I'm going to have to take my 100% of the hat plus my 6% tax, and I'm going to multiply that by 32. So notice what I did is kind of put together a distributed property type of problem. And that's what I did right here. Notice 32 times the 6/100ths is the $1.92, and then there's my 32 right there. But again, look at this. This 1 and the 6/100ths, they're constant terms, so they're like terms. Can I add those two together? So instead of having 1 plus 6/100ths, I'm actually going to rewrite that as 1 and 6/100ths. And I'm going to multiply that by 32 instead. So eliminating that problem right there. Instead of just multiplying by that tax, multiply it by 1 and then that tax together. So let's look at what 32 times 1 and 6/100ths is. It's $33.92. Okay. Can you do it this way? Sure. But again, this is just a nice, quick, least amount of button pushing on calculator as possible. Okay, so a nice little tip and trick when we're dealing with sales tax. All right, now let's go ahead and look at this last one. It says a few of the group members are also thinking about getting water bottles. They're originally $8, but are on sale for 20% off. Okay, so again, what's the sale price of the water bottles? Well, a lot of times we like to start with that $8. And again, we're going to multiply it by that percent off. So 20% is our 2/10. And this is going to give me how much we save. We save $1.60. So again, then students are going to take the $8 at its original, and we're going to subtract $1.60 from it, which gives us $6.40. Okay? A couple steps in there. What I like to do is I like to see that I'm getting 20% off, so I'm going to multiply the original price by how much I still have to pay. Okay, so let's look at this. Original price is $8. How much of that $8 do I still have to pay? Well, if it's 20% off, I still have to pay 80% of that water bottle. So let's go ahead and see what 8 times 80% is. $6.40. Okay, so again, a nice little tip and trick. Instead of having two steps there, I just did a quick little computation, 100% minus 20%. I still have to pay 80% of that water bottle. So I've got a grand total of $6.40. Okay, 3 nice little quick ways to get the answer effectively. All right, go ahead and get out your notes and vocab for this section. Okay, I didn't get the objectives on these notes, but it is just to use percents to solve real life problems. Okay, just reading through that top part, it says percent of change is the ratio of the change in an amount to the original amount expressed as a percent. Again, when we look at that word change, that's why we're subtracting there. So here's our new fancy formula. It says if the new number is greater than the original number, the percent of change is the percent increase. If the new number is less than the original number, the percent of change is the percent of decrease. But I also put over here that if we do use this formula and our answer comes out negative, that tells us it's a percent decrease. If it's positive, we know it's a percent increase. So again, let's go ahead and look at example 1. Again, first we have to determine whether each percent of change is a percent of increase or a percent of decrease, and then find the percent of change. The increase and decrease, all we have to do is look at this. We have a higher final than we do an original, so we know that this is going to be an increase. Okay, now we're going to plug the numbers into our formula to make sure that our formula says the same thing as that. Okay, so let's go ahead and look at this. New minus original over original. Final is going to be our new number. So plugging it into the formula, we have 23 minus 20 over 20. I'm going to bring out my fancy calculator to show us, again, how to put this in there. Since we do have a numerator that has a couple things going on, that's when we have to use those parentheses again. So we're going to take 23 minus 20, and then we're going to divide that by 20. And we understand that that's 0.15. Again, to get that into a percent, we can either move it over twice or multiply it by 100. We know that this is a 15% increase. Okay, looking at B, again, our original was 25. It looks like our final is smaller, so this should be a decrease. Here we had a positive 15, so that did coincide with our increase. We're going to say that this one's a decrease, and our answer should come out negative. So new is 17 minus our original, and we're going to divide that by our original. Okay, can you do some quick math in your head so you don't have to put that numerator? Sure, that's fine. Divided by 25. Again, there's my negative. So when I write this, we're not going to write it as a negative 32%. We are going to say that it's a 32% decrease. That decrease is there to help us with the negative part. Okay, go ahead and try guided practice 1. Okay, these are a little bit different because the answers don't come out quite as nice. So when we get crazy decimals like this, remember we have to move that decimal point place 2 places to the right. So doesn't come out perfectly. On this one, we could have said about 55% or about 54.5%. This one about 23.5%, about 66.7%, and this one comes out as an even 73.8%. Okay, so when in doubt, use that about to kind of save yourself. All right, moving on. On this example 2, it says the total number of passengers on cruise ships increased 10% from 2007 to 2009. If there were 17.2 million passengers in 2009, how many were there in 2007? Well, that's kind of tricky because they give us the actual percent. So let's go back to our formula. Remember, our formula is new minus original over original. And what that gives us is the percent. So here I'm just going to use that formula and fill in what I know. Okay, there were 17.22 million passengers in 2009, which is going to be our new number. So I'm going to put 17.22 in for my new. I don't know my original because they're asking what it was in 2007 and that was my original. So if I don't know something, remember I'm going to give it a variable, and maybe I don't like that because that kind of looks like a 0, so I'm going to say x. And I'm going to divide that by x. And up here I'm going to say x is 2007 passengers, just to remind myself what I'm dealing with. Okay, I know this all equals 10%. So remember that I don't use a percent sign in a problem. I'm going to have to convert that to decimal form. So 0.10. All right, looks like kind of a crazy type of problem, but I have variables. I think I should be able to solve this. So that x is in the way. I'm going to have to get rid of it on both sides. So I'm going to multiply by an x on both sides, which gives me 17.22 minus x equals 0.10x. Okay, I have a variable on both sides, which means I have to combine like terms. So since he's negative, I'm going to add an x over to this side. So I'm adding a 1x. So I have 17.22 equals 1x plus a tenth of an x is 1 and a tenth of an x. Okay, looks like I'm getting closer. I have a 1.1 multiplying by that x, so I'm going to have to divide by 1.1. So passengers in 2007 is 17.22 divided by 1.1, which gives me about 15.65. So x equals 15.65. What is that dealing with passengers? In million. So 16.65 million passengers. That's why that formula is kind of nice, because if you have a problem like this where you have an unknown, write out that formula, plug in the pieces that you know, so you can solve for the pieces that you don't know. So go ahead and use that concept on guided practice 2. Okay, same concept as last time. Again, we knew the new, we didn't know our original. On this one, be careful that we move that decimal place 2 to the left. So our percent change written as a decimal is actually 0.054. Okay, so we should have had a grand total of $31,696.39 for the original cost per year. Okay, so there's percent of change. Now let's go ahead and look at that sales tax using our nice new formula. So looking at example 3, Marta is purchasing wire and beads to make jewelry. Her merchandise is $28.62 before tax. If the tax is 7.25% of the total sales, what is the final cost? So again, we decided that we're going to take the cost and we're going to multiply it by 1 plus the tax. So I'm going to take my 2862 and I'm going to multiply it by 1 plus that percent of tax. Well, again, moving that over 2 decimal places, that's what I'm going to multiply by. So 28.62 times the 1.0725 gives me a grand total of $30.69. Okay, quick and easy. I didn't have to, again, hit too many buttons on the calculator. So go ahead and use that concept for guided practice 3. Okay, pretty simple concept. The only thing is just to remember to move that decimal place 2 to the left. All right, last one. Looking at discounts. It says, since Tyrell had earned good grades in school, he qualifies for the good student discount on his car insurance. His monthly payment without the discount is $85. If the discount is 20%, what will he pay after each month? So again, our little formula was that we take the original price and we multiply it by the percent we still have to pay. So a little bit of quick math in our head, but it does help us just to quickly find the answer. So original price was $85. If we have a 20% discount, that means that we still have to pay 80% of the price. So 80% of 85 is $68. I really wish my car insurance worked like that. Okay, quick and simple, nice little formula. Go ahead and try it for guided practice number 4. Okay, you should have got an $8.93 picture frame. One thing before I forget about it, I've had kids, once we get to that wholesale one, they get to an assignment and we have sales tax. And they get really confused about, well, does that mean it's on sale for 6.85% off, or what does that mean? So if kids aren't used to money, aren't understanding what that means, please reiterate that sales tax is an actual tax. Don't look at that word sale. It doesn't mean it's on sale. It's just a tax that they have to pay. Okay, so maybe just a little bit of real life vocab that you might want to go over. Otherwise, you should be ready for the assignment for this section.